Howdy, 8th grade. Today we're going to be looking at how to solve some compound multi-step inequalities, which sounds kind of crazy. I promise it's not that bad. But I want us to first remember, so bit of review, is that compound inequalities are inequalities that use or and, or they look like x1 is less than x is less than 5. So this is another compound inequality, and this is the kind we're going to look at today. So this bottom one where we got things in two different directions on the x, or saying a couple different things about it at the same time, how we're supposed to solve those. And it's actually pretty much the same thing we've been doing this whole time. So we're going to look at a couple of example problems real quick. So if I have, we're going to do 3x plus 2, and over on this side we are going to have 32, and on this side I want to have 17. Brilliant. So looking at this, if I want to solve it, my goal is definitely going to be to get x alone. This is my first example. Let me label that there, example. So my goal is to get x alone, and x is right here. So normally, to get x alone, I would look and I'd say, well, I want to get rid of this 2. So I'm going to subtract 2, and then I do it to the other side. But now I have two other sides. So what do? Well, I do it to both of them. So I got 3 sides. I'm just going to make sure I do the same thing to all 3. So I subtract 2 from the middle, from the right, and from the left. And then I'll end up seeing that 15 is less than or equal to 3x is less than 30. Divide by 3 to get x alone. Have to do it to all 3 sides. And I end up with 5 is less than or equal to x is less than 10. And that's pretty much what today is looking at these compound inequalities that maybe have multiple steps and being able to solve them. So let's look at one more, and then we'll go from there. If I have 5x plus 7 less than 25 and is greater than 10, my question is going to be, how do I solve this? And a lot of times when we look at these, this is going to be a tip for not just this kind of equation, but a lot of them. I would distribute my 5, which is entirely okay to do. I can do that. But I think there's an easier thing to do. So I could distribute the 5 first and go from there. Or I could say, well, this whole bit right here is being multiplied by 5. So to cancel the 5 out, I'm just going to divide by 5. Divide that whole thing by 5. I'm going to do that to every side I got. So by doing that, this 5 is going to cancel out here. 10 divided by 5 is 2, which is now less than x plus 7, which is less than 5. Not too bad. Now I just need to get rid of this 7 here, which I'll do by subtracting, not 2, subtracting 7. That'll cancel out, and I have to make sure I do it to both my other sides. 2 minus 7 is negative 5, which is now less than x is less than negative 2. And that's how that's going to look. It's pretty simple. I want to make sure we do one more example so we can do something with multiplying and dividing negatives. So we'll see how that looks, and we will be all finished up for today. So if I have negative 3x plus 7, and this is going to give me, let me make sure I'm getting this right, a 1 over here and a 25 over here. So if I'm doing this correctly, what I should be able to do is get this x by itself. So this is another example. Let me make that really clear, real clear. So I want to get this x by itself, and the first thing I want to do is to get rid of the 7. It's going to subtract 7 here. And if I do it to the 1, I have to do it to every side of the equation. 25 minus 7 is going to be 18. The 7s will cancel out there, and I have negative 3x. And 1 minus 7 is negative 6. So I have negative 6 is less than negative 3x is less than 18. So now I need to divide by negative 3, divide by negative 3, divide by negative 3. And my negative 3's here in the middle are going to cancel out, leaving me just with x, which is what I want. But wait a second. I divided by a negative, and this is an inequality. So when I do that, I need to get rid of these signs, and they're actually going to flip right around. And I have negative 6 divided by negative 3 is 2, which is now greater than x, which is greater than negative 6. So if we notice, if we didn't flip these, I would have said that 2 is bigger than something that's bigger than negative 6. That's what it says right now, after having flipped them. If I didn't, it would say 2 is less than something which is less than negative 6, which would mean 2 would have to be smaller than negative 6, which doesn't quite make sense. So what we're doing, what we're making sure we do, is if we divide by a negative, we flip it. And since there's more than 2 sides to these equations, the only real difference here is we have to make sure that we keep all of the equations where they're supposed to be. So I'm just going to graph this real quick so we can remember what that looks like. 0, 1, 2, 3, 4, 5, and 6 right there, which makes this the 2. So if we're doing, if we're doing things without an equal sign on the bottom, so that is not there, that means that my circles are going to be empty like they are. They're not going to be filled in. And I need my x to be bigger than 2. Oh, I drew this the wrong way. That's a negative 6, not a positive 6. I was confused because it said x needs to be smaller than 2, and I had it pointing the other direction. Here we go. That ought to work better. So now that I have my negative 6 here and my 2 here, those are still going to need these circles. And again, the circles are empty because I do not have an equal sign in that equation. So I know that 2 is bigger than x. That means that x is less than 2, so that's headed in this direction here. And I know x is bigger than negative 6, which is going to be in this direction here. And they're just going to join up in the middle there, and I'm going to be all finished. So this right here would be how I would graph the solution. In any case, I will see you all in class tomorrow, and have a great day.